Okay, for this question, you see that there are three statements, P, Q, and R, three prepositions, and each of those could be true or false. So you have to start out by preparing PQR to be all the possible combinations of true and false. Okay, so TTT, and one way to make sure that you didn't miss out anything is to like fix the first two and then change the later, and then only when you run out of options then you change this later one. Okay, so TT is fixed. I don't change it, but then this can change to F, right? But then T and F are the only choices for the R, therefore now I have to change this. So what's after TT? Which means I'm fixing T, I don't change T, but this can be changed. Changed to what? Which one? F, right? Yeah. And then with T and F, R has two choices, T and F, right? So TF, so TFT, TFF, and then you can also have FT with TF, and then FF with TF. Okay. Now, if that's confusing, another way to approach this is to build a tree. So, for example, P could either be T or F. And then if P is T, Q has two options. It could be T or F, right? And then if it's TT, R could also be T or F. Same thing here, it could be T or F. And then for F, Q can also be T or F. FT, you can have TF. FF, you can have TF. That tree-like structure actually gives you all possible outcomes for PQR, right? At every stage, every scenario is covered. At the initial stage, P would be either T or F, right? And then even if you choose T, Q could be T or F. Both are covered, and both scenarios are covered. And if you have TF, then R could be T or F. So every possibility is shown in this tree diagram, and you can see that you have total 8 possibilities. And the way you read this is you go TTT, which is the first guy, TTF, TFT, TFF, FTT, FTF, FFT, FFF. So we wrote down all the possible combinations of PQR. Is that okay? Right. Now, it's hard to tackle everything at once, so we're going to compute P implies Q, and P implies R. And only after we compute each of these, we're going to compute P implies Q implies P implies R. Okay? So when does P implies Q evaluate to false? Do you remember?
When Q is false and P is true.
True, yes, that's exactly right, yeah. So only when P is true and Q is false, if then statement, this implied statement gives you false, all the other cases is true. Right? So let's look for that P implies Q here. These two cases are the cases when P is true and Q is false, right? So those are the cases you have false. All the other cases are true. Okay. Same thing for here. P implies R has P. We need P true and R for false, and it's these two, right? TF, TF. Those are the cases when P implies R is going to be false. So put false there, but everything else it's going to evaluate to true. So we put true. And then you have this implies this, Again, look for TF. I see a TF here. And that's it. That's the only case, right? That's the only case I see a TF. So that's the only case we get F, and all the other cases I get true. Now, if a statement comes out to be true for all cases, then in that statement is called a tautology. So, for example, if you did P and Q implies P or Q, that's a tautology. You can build all the possibilities of P and Q, and this will always evaluate to true. And you can also try to argue why this is true, because if both things happen, then you can always say one of the things happened, right? If P and Q is true, then at least P will be true, right? Therefore, P or Q will always be true. Because for an or statement, if you have one thing that's true, that's always true. So that's a tautology. That's called a tautology. Whereas the converse wouldn't be true. P or Q does not imply P and Q. Because this will be true even if P is true and Q is false. And in those cases, the P and Q will value to false. And you get the case when T implies F. So that's not always true.